Hello, it's Mrs McTaggart here again, and in this video we're going to be finding the area of a sector. So you should maybe have already seen how to find the arc length of a sector and realise that a sector is like a pizza slice or like a Pac-Man kind of shape. So we're going to be looking at area. It is the exact same as finding the arc length. The only difference now is that this formula changes from being pi d at the side at the end to being pi r squared. And again, this one is not on your formula sheet, so you need to memorise it, okay? And you should have already met the area of a circle formula. There's a great wee song, if you search it on YouTube, type in circumference song, and it brings you up where a man sings about the formula for circumference and area, and it gets stuck in your head and hopefully you will learn it. So it's angle over 360 times pi r squared. I always say, well, area, you write cm squared at the end, so area is the one with the squared in it. And you know what, I found out if you're in the exam and you can't remember which one it is to use, have a bet, and if you accidentally use the wrong one, you only lose 1 mark. So it's worth taking a gamble and 50-50 chance of using the right formula, and as long as you employ it correctly, we can still pick up quite a lot of marks. So for this one here, I'm going to go straight to the working. So it's my angle, which is 280. So I'll start with area equals my angle over 360 times pi times, now my radius here is just that 25, so it's times 25 squared. And when you go to your calculator, you can use your little fraction button if you want, or remember it's much quicker to just type 280 divided by 360. That's what I do, and then you should get an answer of 1527.163. I'm a 2 decimal place fan, so that goes to 16, and it's square centimetres at the end because we are talking area. And that's it, dead straightforward. So most people find these questions really, really nice. As long as you remember the formula, know the difference between radius and diameter, plug it in, type it in, there you go. Let's look at another one. Let's try and make it a bit harder. So they can present you one where the angle at the centre isn't given. But what we can see is this is a full circle. And we know a full circle is 360 degrees. This has been split into 5 sections. So 360 divided by 5 is 72 degrees. So that angle in here is 72. So my area is my angle of 72 over 360 times pi. Now my radius there is 12 times 12 squared. And if you type that in, you will get an answer of 90.477, so 90.48 centimetres squared. And that's it, we've found that little yellow sector. And then other than that, the only way I can make this question a little bit harder is this one here. I always like a non-calculator one at the end. So this technically should be example 4. It says number 3. So without a calculator, again, we're looking for a really simple calculation. But let's start with a formula. So we know it's area equals your angle over 360, so 45 over 360 times pi times your radius squared, so times 20 squared. Right, so as always, let's start by simplifying that fraction. You could think, oh, they're both in 9 times table. I know better. I know they're both in the 45 times table. So 45 goes in once there, and 45 into 360. Well, every 2 45s makes 90. So you've got 4 lots of 2, so it's 8. That is 1/8 times 3.14. And 20 squared is 20 times 20. If you need to, go to the side and do the good old trick. 2 times 2 is 4. 2 zeros in the question, so it's 400. You should be able to do that mentally. And again, the fraction in the 400 can simplify. 1/8 of 400 is 50. So I'm left with 3.14 times 50. Which, to do that, I times by 10 first of all. So you've got 31.4 times 5. 5 4s are 20. 5 1s are 5, add 2 is 7. 5 3s are 15. So I've got an answer of 157 square centimetres. Now we're kind of limited to what we can do with these ones. We're limited to what numbers we can square and then simplify. So I think I've only seen 1 or 2 of those ones in past papers. But that's me showing you my 4 to give you one a bit like this. So this was pulled from an exam paper, quite an old one. It's talking about a dog collar. And if you've ever seen one of these dog collars, the cone shape. If you fold that out flat, the net of it looks like this shape here, and hopefully it should jump out at you. That what we actually have is we've got a big sector and we've got a little sector cut out of the middle. So what we have to do is find the big sector. So you've got your large sector and then you've got your little sector cut out. Now the large sector, all the information is given to you in the story. It tells you that O to A is 10 inches. So on the little one, O to A, the radius is 10. And on the big one, O to C is 18. So on the big outer one, you've got an 18 in there. And they both share the same angle of 160. So what we have to do here is big area, take away small area. So the big one will be 160 over 360 times pi times your radius squared, so times 18 squared. Your little one, I'm going to write wee because it's smaller, it's less writing, would be same angle, 160 over 360 times pi times a radius of 10 squared, which to 2 decimal places gives me an answer of 452.39 and 139.63. For the last bit of the question, I then have to subtract them. So my area is the big one, take away the wee one. You could write the numbers in here, to be honest, but I'm just trying to save a wee bit of time. So if you subtract those two numbers, you will get an area of 312.76 centimetres squared to 2 decimal places. Okay, now the one last question I have to do, all that's left now is to show you this page here where you can try some for yourself. You can screenshot the page and try them. You've got the answers at the bottom. As always, I've put in some non-calculator ones as well because I like to test those skills. So I hope this has helped. Thanks very much for watching. Bye bye.